We have three problem statements to be given for introduction, and 7, 8, and 9. Right now, people regarding 7 are not available. So we'll continue with problem statement 8 and 9. So over to Neeraj sir. Sir, you can start. Any initial remarks from Hack to Skill team?
Um, we can have the closing remarks just like in the previous session after the
Okay,
problem.
fine. Then we'll start with this section. Okay, sir. Neeraj sir, you can proceed.
Dr. Vamshidhar, from our side, Dr. Megha is going to present. She is just joining. And meanwhile, just I would like to tell the students that in this project, what you will be using the IRS data on board Chandrayaan 2. So IRS stands for this infrared imaging spectrometer. Okay, that is currently observing the moon's surface. Okay, and it is acquiring images in 256 spectral channels. So when we acquire the reflected images in so many channels, what do? We derive the compositional differences on the surface. Not only composition, it can be also the grain size differences, the physical parameters of the surface also change from one area to another area. So this is what we want to target in this project, and the further details will be told by Dr. Megha Bhatt. So Megha Bhatt, please, over to you.
Yeah. Okay. So I will be explaining the project. So as Dr. Neeraj Srivastava already said, it's basically spectral classification of Chandrayaan 2 IARS data using AI ML for understanding geological diversity of the moon. And what we what we expect is that students should know little bit about image processing and machine learning and software platform in general. What they can use is either Python or MATLAB. What will be required, a kind of workflow, is first of all understanding the hyperspectral data set. So for that, we recommend that you should first download a specific data, IRS data, from the website already mentioned in the project, and then you should start playing with that data, plotting and understanding that so you need to know that how you plot this data. You need to, so it's a cube form of the data, so you need to first extract information for every pixel. You need to also put coordinates, latitude and longitude, to these images. Once you do that, the next part will be the data visualization part. That is where you are expected that you can basically plot a data stripe, and out of that data stripe, when you click to any specific point, you can basically display the spectral variation. So you can display the reflectance variation with respect to wavelengths. So that is what expected as the first part what we have mentioned. I'm just trying to, yeah, so that is going to be the first objective: create a visualization data that will aid to classifying the IRS data based on similar data acquisition parameter. And then what we expect is that the thing is that there will be lot of noise involved that will be required to remove. So the next step is data cleaning. So you take some 2-3 stripes of data, and then you have to just take the data where you have a response in a way that reflectance value is increasing with wavelength. If you have any zigzag pattern, that is what you need to discard. Even for that data cleaning, one can apply machine learning approach. So you can either first manually tag the data for a few orbits, and you can develop supervised machine learning based data cleaning, or you can go for unsupervised way of data cleaning also. So that will be on the team how they want to basically approach the problem. After that, what we expect is also the performance comparison. So you are applying a few different data cleaning processes and based on machine learning, and then you are trying to understand that which one is the best. So once our cleaned data is available, after that, so that can be done for only few specific stripes, and that is of your choice. So you can decide, you can basically select, let's say, 1 month of data, and you can basically work with that 1 month of data. The data volume is going to be heavy, so you should have good parallel computing and all. You may need to think of how you will be doing that. And once the clean data is available, the next part is to basically do spectral classification. So one can start with some very basic methods, for example rainforest classification and so on, and then you can go up to applying one dimensional CNN models for basically classifying these 1 or 2 months of data in different clusters. Now you have to again play with this data. You have to come up with with different clusters. So you can decide, let's start with 2 clusters, 3 clusters, 4 clusters, and so on. And once we have that clustering, that can be compared with the general understanding what we have. So that will provide us basically that will be the main objective of this problem, where we will be doing this spectral classification of IIRS data using different AI and ML approaches. The data set what we require, it's already mentioned in the document provided, that you can download it from ISRO's space science data archival. So, and then for supporting data also, it is mentioned that you can basically go to that specific website and can look for previous mission data as well. So I think that is the overall expectation.
I would just like to add here that when you see the data, data will be in the form of radians. So what I suggest to the students is they should go to the website of ISRO and find out how to convert this radiance data to reflectance data. That type of information is available at Pradhan. Right, Megha?
Yes, so you can actually look to user guide. So with the data, there is also a user guide which you can have a quick look, and there you will understand that how you should be plotting the data and how it will be, how you can visualize it and so on.
Yes. Dr. Vamshidhar, any query?
Yeah, that's it. I think very nicely you have explained. Now we will move on to the next problem statement. Problem statement 9.
Okay, thank you.
Vijayan, I think.
Yeah.
Over to Vijayan.
Yeah, let me share my screen so that I can explain. Thank you. Good morning, all. And the problem statement for the ISRO Hackathon is identification of safe navigation routes on the moon using Chandrayaan-3 images. So I'll explain about the project, what is proposed and what students are intended to do. The objective says that coordinates in the southern polar region is given on the website. The students have to use the Chandrayaan images, either Chandrayaan-1, Chandrayaan-2 images that are freely available, and they are want to produce a map or a output from where the rover path can be planned. So the objective says that analyze the landing site region in the southern pole of the region. The coordinates is given. From this point, the students can take any region around this site, and they want to generate a path from that point to at least 100 meters So saying that which direction is useful if any lander or a rover is landing on the lunar surface, and which way is safe. It's not only about the safe, the primary thing is it should include the scientific stops. So this is the objective. And to achieve this objective, so I would suggest of using different data sets from Chandrayaan missions, either terrain mapping camera or the um, DTM or the optical high resolution cameras or from the IERS. So where do you get these images? I'll just give you a quick glance. So this is the Pradhan portal where you can go and download the data. So the Pradhan portal is this, that you have to go for this Chandrayaan-2 image, and you need to either register in this login and then you will get the access to the data. But before that, those who are new to Moon, I would request the students to go to this map browser, which is mentioned here, so that they can enter and they get an overall view about the Moon. As the project says, it is towards the South Polar region. So if you go to this navigation thing, the projection, you can change the view to the South Polar view. So this is the South Pole region of the Moon. And in this region, the coordinates are already given where you want to work on. But how to observe the data or which data set is there, there is an option called layers. If you choose this layer, information layers, you can see the instrument footprints. So these instrument footprints are nothing but the available data from the Chandrayaan mission. For example, I have loaded the CH2 OHRC calibrated product, and the rectangles what you're seeing on the image are the ones where the images are available. So the students have to choose accordingly the coordinates given in the project, and they need to download the particular images. From the same link, you can download the Chandrayaan-2 TMC calibrated images. So there are a lot of images available. That means a lot can be interpreted. Though this TMC is an optical image, this is the coverage for the same region. There are other products like Chandrayaan-2 TMC, the DMT product is also there. So the students can also able to download the DTM data for the specific lat long given in the objective. Along with that, the other data set IARS is also given. The students can have a glance and they can go ahead. Now, going back, how to download the data. Once you register and log in, you will get the portal like this. So here, each option shows about the different data sets, the terrain mapping camera, the OHRC data, the IARS data sets, and other data sets. So in this, they can choose the specific data sets for their analysis and they can move forward. If you just go into OHRC, there will be plenty of data sets. You can move towards by a search or identifying based on the ID. We can filter the image which is given in the project proposal. So what is the softwares or tools? There are some softwares like QGIS and ArcMap, and even any other open sources or licensed software can be used for students. Once they get the image, they are encouraged to observe what are the things there and what can be done. For example, I'll just say one small example. This is the place exactly where the Vikram lander landed and the rover has gone this side. So what decides the mission for the rover to go in this direction and not in the other direction? So there is a specific reason for it to move towards in this direction. So that is the one major outcome that is anticipated from this project. The students are requested to make a path for at least 100 meters and with at least 10 stops, because the objective of the rover is to go explore different places. So why those 10 stops are chosen and what is the scientific significance, that we can tell from that also the students have to tell. And students can do any sorts of image processing or classification. They can generate an output map, and it is at last the rover has to cross at least 100 meters in a safe way, with importantly the scientific exploration on its way. So any query, just WhatsApp me. in the group. Thank you.
Yeah, thank you, Vijayan sir. Are you done with this one, sir?
Yeah.
Yeah, okay, fine. I think today almost out of 12 problem statements, I think we have completed 11. Only one is pending. Anyway, that also we are trying to get them over online or recorded message. So I think we are getting very good response from all the students. Actually, students community is actually backbone for our what you call this space hackathon program. I think they are showing very good interest. I will also expect some more registration from all the students. So we'll go with a grand success with this finale, which will encourage even ISRO to organize much more hackathon programs. So hack to skill. Anything you want to add?
Yes, so thank you to all our speakers for their valuable insights and for our audience as well for joining on such a short notice. Remember, the last day to register and submit your ideas for this hackathon is 26th of July. For all the students who have joined us today, we hope now you have a better understanding of the problems that we discussed. For the remaining problem statement, as Tishi has mentioned, we will let you know when the session is going to be there. Meanwhile, let me reiterate some of the important things to keep in mind. Once you register for the hackathon, you have to form a team with a minimum of 3 and a maximum of 4 team members. Next, you have to obviously submit your idea, for which if you need any help, then you can go to your dashboard, and from there you can refer to the resources section and can access these problem statement explainer sessions again to have a better clarity. And like Neeraj ji and Megha ji have mentioned, you can also visit the ISRO website and refer to the user guide in case you need more information. Rest, if you're still facing any queries, feel free to reach out to us on the WhatsApp group or email at isrohack@hacktoskill.com. We are also dropping the email ID on the chat section. We wish you all the best in your hackathon journey. Let's innovate and shape the future of space technology together. Thank you.
Thank you. All the best to all our students. We'll meet you soon.